say when I'm multiplying? Yeah. So now I'm telling you I can first tell you what convolution is, and then what cyclic convolution is. And this is real. Listen up to this because it's a good thing to know. Yeah. So first of all, convolution. So suppose I want to take the convolution of 3, 1, 2. That's often the symbol for convolution with 4, 6, 1. Okay. So what does that mean? I've got a vector. So what's hiding, for me, what's hiding there is polynomials, 3 plus x plus 2x squared times 4 plus 6x plus 1x squared. And I just multiply them out, and I get 5. So I get 3 times 4 gives me a 12. 3 times 6x is 18x, but I've also got 4x from here, so I've got 22x. So I just do that multiplication of polynomials, and what I'm doing is convolution with the vectors. And here's the way you wrote it in first grade. Okay, so here's first grade. Okay, 2, 12, 8. This is, you haven't learned to carry yet. So 12 goes in there as 12. Then 1 is 4, 6, 1. And 3 is 12, 18, 3. And then you add up. So you have 2, 13, 17, 22, and 12. Let me just, so that's the answer then. That the convolution, I guess I have to take it from, 12. 3 times 4 gave 12. Now 3 times 6 plus 1 times 4, that's the 22. Oh yeah, we already started here. But now, what's after that? 17? Why did I say 17? Oh, 8 plus 6 plus 3. Thanks. 17. And then 12 plus 1, 13. And then 2. That's non-cyclic. So that's convolution. Oh, if I want it to be non-cyclic, I don't put a circle in. So that's the symbol for ordinary convolution. If you do the MATLAB command conv for convolution, if you gave it those vectors, it would give you a vector with 5 components as a result. But if you now let me make it cyclic. Okay, so what's going to happen now when I make it cyclic? So this represents 12, 22p, 17p squared, 13p cubed. And what happens? What's 13p cubed if n is 3 and I'm doing 3 by 3 matrices? Then 13p cubed is the same as 13, right? P cubed is I. So the 13 will go back there, and the 2 will be p fourth, and it'll go back as p. So now with convolution, cyclic convolution, gives 12 and 13, 25, 22 and 2, 24, and the 17. Okay, so I'm getting back a vector of length 3. Just as I want to do. If I have a 3 by 3 matrix, a convolution cyclic circulant matrix with those 3 diagonals and these 3 diagonals, then I want the answer to be a 3 by 3 matrix with these diagonals. So again, matrix multiplication of circulant matrices corresponds exactly to multiplying polynomials cyclically, and that's cyclic convolution. And then there's just one little trick to see if you got the numbers right. I believe that it should be true that if 3 plus 1 plus 2 is 6, 4 plus 6 plus 1 is 11, and I believe that those should add to what? What do I hope that they add to? 66. I'm a little nervous about doing it, but I think we can. Yeah. So 49, 59, 66. Check. Yeah. So the digits, the sum of the digits of one factor multiplies the sum of the digits of the other factor to give the sum of the digits in the convolution. And that would be true whether we're doing cyclic, which is bringing the 13 and the 2 back in, or not cyclic, where we have 5 numbers. Yeah, so that's actually a check that I don't know if you ever thought about that in second grade. Multiplying these numbers, multiplying that number by that number, and getting some answer, which probably half the class did not get, right? Then 5th grade, they're kind of getting it. But if they knew a check, so they could have just added these numbers to get 11, added these numbers to get 6, multiplied those to get 66, and checked that those added to 66. That never occurred to me, I admit, in second grade either. But it's a good thing. Now you know. Now you can pass second grade. Okay. So